Hello, my name is Rob and I'm doing a video for my Pidp course 3240 for Vancouver Community College, and this is my online educational video. So today I'm going to be going through a series circuit, and we'll go step by step doing the calculations on a series circuit, and hopefully by the end of this video you'll understand how to calculate a series circuit. Okay, so a series circuit in an electrical system is a circuit where the current will run through one resistor and then through the next resistor and through the next one and so on and so on. Okay, so series means it runs from through one and into the other. Okay. So for some rules of a series circuit is total resistance equals the sum of all resistors. Okay. All voltage drops equals source voltage. Alright. So what are voltage drops? We'll get into that in a minute. And the sum of all resistors, we're going to need that to do our calculations with our Ohm's law. Okay, so Ohm's law is a formula that we use quite often in the heavy-duty equipment technicians trade for our electrical program. And Ohm's law is volts equals amps times resistance, or the most common way you might see it is E equals I and R, where E is the electromotive force, I is your inductance, which is the same as our amperage, and R is our resistance. So our electromotive force is the same as our volts up there. Alright, so using a trades triangle, we can take this formula here and put it into a trades triangle, and I personally like to use the trades triangle along with most of my students. So when we figure this out, E is going to be on top, and then our I and R on the bottoms here. Okay. So to complete a triangle, we need at least two pieces of information in our triangle, and we can now take information from our circuit that I've drawn over here on the board and put it into our triangle. Okay, so what I've done here is I've drawn just a very simple series circuit. I have a 12 volt battery, a couple of resistors that I've labeled resistor 1 in green here and resistor 2 in blue. Okay. So one of our first rules for a series circuit is that total resistance equals the sum of all resistors. So that's quite easy in this circuit here. We have a 2 ohm resistor and a 1 ohm resistor. Add them up, that's going to give us 3 ohms of resistance. Okay, so once we have a total resistance, we can put that into our Ohm's law triangle here. So 3 ohms. Okay. Now our voltage, which we are saving from a 12 volt battery here, or we're taken from a 12 volt battery, sorry. So that's our total voltage source. So we can simply just put 12 volts up on the top there. So as I said previously, we need at least two pieces of information in our triangle to complete it, and it's quite simple. We go 12 divided by 3 is going to give us 4. Amps. So there's 4 amps of current flowing through this circuit. So I'm just going to go ahead and draw a little circle here and put my 4 amps there, just as a reminder for when I'm doing my calculations later on. Okay. So resistance is the sum of our resistors, and we got 3 on that. We got a total of 4 amps now in our circuit, and we got a source of 12 volts. Okay, so we have done the math for that complete circuit now. Now we can break it down and find our voltage drops for each individual resistor. And remember, all voltage drops equals source voltage. Okay? Since current is always going to be constant in a series circuit, the current is going to be our constant in our triangles for doing our voltage drops. So all I've done here is we're going to use Ohm's law again, but we're going to use it for each individual resistor. So my resistor 1 here, I've drawn a green triangle for that, and resistor 2, I've done a blue triangle for this. Okay. So we can go ahead, because I said amperage is constant throughout a series circuit, that is going to be our constant. So let's do the resistor number 1. So we got 4 amps. Okay. Our resistance for this resistor is 2 ohms. So we can go ahead and put our 2 ohms in there. And again, now we have 2 pieces of information in our triangle. We can easily figure out our voltage drop across that resistor, and it's simply 4 times 2 is 8. Okay. So if we were looking at our multimeter, like the one in the picture, it will show us what we would be reading across that resistor. So when we're using our multimeter, we want to have it in DC voltage, okay? And that's gonna, for this particular lesson here, and that's what we would read our voltage drops. So what I've done here is I've just drawn a couple voltmeters like the one you've seen in the picture. Not quite as nice as the ones obviously in the picture, but it works pretty good. So if I was using that multimeter and I was going across that resistor, I would simply read 8 volts. And that's what we calculated there. Okay. So let's move on to resistor number 2. So again, 4 amps is going to be constant throughout our entire series circuit. So since our amperage is constant, we're going to put in our 4 amps into our triangle there. The resistance of resistor number 2 is 1 ohm. Right. So now we just do our math. 4 times 1 is 4. And we're going to get 4 volts. Okay, so again, if we were using that multimeter like the one in the picture there, and across that resistor, we would read 4 volts. Good. So remember our second rule here, all voltage drops equal source voltage. Well, let's see if it applies. We got an 8 voltage drop across resistor number 1, a 4 voltage drop across resistor number 2. Add them together, we're going to get our 12 volts, and our source voltage is 12. So you know you've done your math right, and you know you've done your calculations right when you can go back and all your math adds up, right? Thanks for watching. Have a good day.